Section 3.1, Graphing Linear Equations. Essential question. How do you determine if an equation represents a linear or nonlinear graph? Alright, so we're going to graph the equation y equals 3x minus 1, and we're going to determine if it's linear or nonlinear and if it's a function. In order to graph an equation, we need to make a table in order to create a set of ordered pairs that we can graph. You always want to choose a couple negatives, 0, and a couple positives to give you a good idea of what a graph is going to look like. So we will pick the values -2, -1, 0, 1, and 2. So if I plug -2 into my equation, I'll have 3 times -2 minus 1. Well, 3 times -2 is -6. -6 and -1, or -6 minus 1, makes -7. 3 times -1 minus 1. Well, 3 times -1 is -3. -3 minus 1 is -4. If I plug in 0, I have 3 times 0 minus 1. 3 times 0 is 0. 0 minus 1 is -1. 3 times 1 minus 1. 3 times 1 is 3. 3 minus 1 is 2. And 3 times 2 minus 1. 3 times 2 is 6. 6 minus 1 is 5. So here is how I get my ordered pairs. I take my x value and my y value. So -2, -7. My x value and my y value. X, y. X, y. X, y. So -2, -7. -1, -4, 0, -1, 1, 2, and 2, 5. If I connect my 5 points, I end up with a straight line, so it is linear. And is it a function? Well, for every graph, I have to do the vertical line test to determine if it's a function. So if I make vertical lines through my graph, each one of these red lines is only touching my green line once, so it is a function. So I'll say yes, passes the VLT, which is the vertical line test. All right, 2x squared minus 5. I put my 5x values down, -2, -1, 0, 1, and 2. Keep in mind you really could pick any x values you want. I could pick 85 through 90 if I wanted to. I could pick -10 through -15. It doesn't matter what x values you choose. But I'm choosing 2 negatives, 0, and 2 positives to get a range. So 2 times -2 squared minus 5. Well, -2 squared is -2 times -2, which is 4. 4 times 2 is 8. 8 minus 5 is 3. 2 times -1 squared minus 5. -1 squared is 1. 1 times 2 is 2. 2 minus 5 is -3. 0 squared is 0. 0 times 2 is 0. 0 minus 5 is -5. 1 squared is 1. 1 times 2 is 2. 2 minus 5 is -3. 2 squared is 4. 4 times 2 is 8. 8 minus 5 is 3. All right, so if I graph those 5 coordinate points, I've got -2, 3, -1, -3, 0, -5, 1, -3, and 2, 3. So this graph will create a parabola if I connect the dots. Parabolas are nonlinear because they're not a straight line. And if I perform the vertical line test, my red line is touching my blue line once each time, so it is a function. So yes, passes the VLT, the vertical line test. All right, 4 divided by x. So if I put down my x values, -2, -1, 0, 1, and 2. 4 divided by -2 is -2. 4 divided by -1 is -4. Now with 0, 4 divided by 0, well, any number divided by 0 gives you an error. So we're not going to want to do that point on this one. 4 divided by 1 is 4. 4 divided by 2 is 2. So now I've just got 4 coordinate points on this one, but that's just fine. -2, -2, -1, -4, 1, 4, and 2, 2. So you'll notice that these lines actually do something like this. So that is not a straight line, so it is nonlinear. And if I perform my vertical line test, it is a function, yes, it passes the VLT. All right, now I've got the absolute value of x. So the absolute value of -2 is 2, because the absolute value is always positive. It's the distance from 0. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. Absolute value always creates a V. A V is nonlinear. And if I perform the vertical line test, it is not a function. Or excuse me, it is a function. So yes, it passes the VLT. All right, 2 to the x power. So -2, -1, 0, 1, and 2. So 2 to the -2nd power, we're actually going to end up with a fraction. You actually end up with 1 over 2 squared, which would be 1/4. 2 to the -1st power will be 1 over 2 to the 1st power, which is 1/2. 2 to the 0 power, anything to the 0 power is always 1. 2 to the 1st power is 2. 2 to the 2nd power is 4. So if I graph those 5 points, I have -2 and 1/4. Oops. Yep, -1 and 1/2. 0, 1, 1, 2, and 2, 4. So it actually ends up being a curve that goes very close to your x-axis but never quite touches it. So it is not a straight line, so it is nonlinear. And if I perform the vertical line test, it is a function because it passes the vertical line test. X to the 3rd power. So -2 to the 3rd power would be like -2 times -2 times -2. So -2 times -2 is 4. 4 times -2 is -8. -1 to the 3rd power, well, -1 times -1 is 1. 1 times -1 is -1. 0 to the 3rd power, 0 times 0 times 0 is 0. 1 to the 3rd power is 1. And 2 to the 3rd power would be 2 times 2 times 2, which is 8. So -2, -8, 1, 2, 3, 4, 5, 6, 7, 8. -1, -1, 0, 0, 1, 1, and 2, 1, 2. So if I connect my points, I've got a slow curve there. nonlinear. And if I check if it passes the VLT, well, if I kept going, I'd keep adding more points out this way and up that way. So even though it kind of looks like it, my line will never become straight. So if it's never straight, it is a function because it passed the VLT. Okay, the square root of x. Now this is the first one where we don't want to have x values with negatives because you can't take the square root of a negative number. The easiest way to make our x value list for this one is to think about what numbers are perfect square roots. So for example, 1, the square root of 1 is 1. The next number that has a perfect square root is 4. The square root of 4 is 2. We could do 9. The square root of 9 is 3. And we could do 16. The square root of 16 is 4. I might not graph all these points because we're getting to pretty high numbers. But if you want to avoid bad decimals, you've got to pick numbers that are perfect squares. So if I wanted to continue, I could do 25, 36, 49, and so on. So this one is a little bit of a unique situation. But 1, 1, 4, 2, 9, 3, 16, 4 would be somewhere out here. So the square root, if you kept going, it's going to be kind of something like that, but it's not going to be a straight line. So we're still going to say nonlinear, and yes, it is a function. All right, 1/2 x plus 3. Now we can go back to our regular table, -2, -1, 0, 1, and 2. So 1/2 times -2 plus 3. Well, half of -2 is -1. -1 plus 3 is 2. Half of -1 is -0.5. -0.5 plus 3 would be 2.5. Half of 0 is 0, plus 3 is 3. 1/2 times 1 is 1/2. 1/2 plus 3 is 3.5. And 1/2 times 2 would be 1. 1 plus 3 is 4. So if I graph those, I've got -2, 2. -1, 2.5, 0, 3, 1, 3.5, and 2, 4. Those are all in a straight line, so they are linear. And is it a function? Yes. All right, so now we're going to do a click and drag for linear and nonlinear. Here's what you need to know about linear and nonlinear. The things that make an equation nonlinear are exponents, square roots, absolute value, and fractions with a variable on the bottom. So let's look for those 4 things. So this one has an exponent. This one has a fraction with a variable on the bottom. This one has an exponent, absolute value, fraction with a variable on the bottom, exponent, and that is, are there more down here? Nope. So I think that's all of them. Everything else is linear. 6x, -4x minus 9, 6, x plus 8, 3x plus 2, 6x minus 8, -1/3 x plus 5, and 1/4 minus 4x. So fractions are okay as long as there's not a variable on the bottom. All right, linear and nonlinear. Let's follow those same rules. So what did we say? We said absolute value is nonlinear, exponents are nonlinear, square roots are nonlinear, got another exponent, fraction fractions with a variable on the bottom. And then the linear ones would be the 3x plus 1 and the 1/2 x minus 3. Let's look at our graphs. Graphs are easier to determine linear and nonlinear. This one's a straight line, so I can go over here. This one is not a straight line. Not a straight line. Not a straight line. Straight line. All right, so what does a linear equation look like? What does a nonlinear equation look like? And how do you determine if it's a function? Well, a linear equation is always going to look like slope-intercept form, mx plus b. A nonlinear equation can have square roots, exponents, fractions with a variable on the bottom, or absolute value. It is a function if it passes the VLT. Summary.